Ask My Instructor 10.2.36. MyMathLab gives us two functions, and they ask us to find a power series representation for G centered at 0 by differentiating or integrating, we have to decide which, the power series for F, and they say we might have to do it more than once. Give the interval of convergence for the resulting series. So we have to play around with the functions a little bit. What would we do to F to get to G? What do you do to F to get to G? Well, you either integrate or you differentiate. If you were to integrate, you'd get some sort of inverse tan. If you integrate F, you'll get some inverse tan thing. That's not going to work. How about if we take the derivative of F? So if we take the derivative of F, ooh, that's looking better. Let's simplify it. Ooh, yes. So the derivative of F is negative 18 times G. So G would be negative 1 over 18 times the derivative of F. All right, so we know what we'll have to do. We'll have to take the derivative. All right, so since we have this is what we're going to do. We're going to find a power series for F. Then we're going to find the derivative of the power series for F. And then we're going to multiply the result by negative 1 over 18. So you have the strategy. All right, so let's find the power series for F. Now, we can just use this geometric formula in order to find the power series, no problem. So, the reason why we can do that, let me just say, the reason why we can use this is that it's being centered at 0. If it wasn't centered at 0, then we'd have to start from scratch. And so it was nice of them to have it centered at 0 so we could use this formula. Now instead of x, I'm going to be using 9x squared. Now x, for the geometric, x has to be between negative 1 and 1. So if we're going to use 9x squared, that's going to have to be between, that's going to have to be less than 1. So that means that x is going to have to be, with the new series, x is going to be have to be less than 1/3. So my radius is decreased with this new series. All right, so as long as x is between negative 1/3 and 1/3, then I can use this series replacing x with 9x squared. So let's do that. And this is what I get. Now I know that I'm going to be taking the derivative, so what I want to do is do that 9x squared to the k. I want to rewrite that as 9 to the k x squared to the k, but remember my power to a power rule, that's x to the 2k. Alright, so I've done step 3. I have found a power series for F. And let me just add in a power series for F centered at 0. Alright, let's find the derivative of the power series. We got to be careful here. When k equals 0, then the term is 1. And its derivative, the derivative of 1, is just 0. So k equals 0. When I take the derivative, there will be no k equals 0. So k equals 0 is now off the table. How about k bigger than or equal to 1? That will work. When I find those derivatives, then this is what I'm, okay, so I haven't taken the derivative yet. Bring the negative 1 to the k on the outside, bring the 9 to the k to the outside. I'm taking the derivative of x to the 2k with respect to x. So go ahead and take that derivative, and this is what I get. Bring down the 2k, and then I have 2k minus 1 is my new power. All right, so it looks like I kind of missed on drawing that box. All right, so this will be what will be the terms of my series. So f is equal to this. That's the series for f, and now I have the series for f prime. And as I said, the first term of the series is k equals 1, since for f, when I took the derivative of f, that first derivative for k equals 0, that first derivative was 0. Okay, also the interval of convergence, that's going to be the same. If you take the derivative or integrate or something like that, that doesn't change the interval of convergence. So we can just keep the same interval of convergence. All right, now what I have to do next is, since g equals negative 1 over 18 times f prime, I have to take my series and multiply it by negative 1 over 18. So let's do that. We're going to take f prime, and what I'm going to do is I'm going to look at it term by term. I'm going to multiply each term by negative 1 over 18. So I'm taking just your general term and multiply it by negative 1 over 18. When I do that, this is what I get. So I had 9 to the k. So the 2 over 18, that's 1 over 9, right? And then I have 9 to the k over 9, so that's where my 9 to the k minus 1 comes from. Now, in terms of the k minus 1 for the negative 1, so I have negative 1 to the k minus 1. I could have written it, and you might think that I should have written it, as negative 1 to the k plus 1. Now, whether it's k plus 1 or minus 1, it doesn't matter. And I chose minus 1 to the k minus 1 because, look, now my exponents match up. All right, so the power series representation for G is this. So this is my power series representation for G. And that makes me very, very happy. But it's not going to make my math lab very, very happy. My math lab likes you to start at k equals 0. All right, so because that first derivative was 0, I said chuck that k equals 0. But the problem now is my math lab's not going to be happy. The terms start at k equals 1 and goes up. My math lab wants the series to start at k equals 0. Now that may seem insurmountable, but it's actually not a big deal. All you have to do, if you want to start at k equals 0, that's fine. All you have to do is change every time you see a k, change it to k plus 1. And so this is what it's going to look like. So I'm starting at 0 now, and instead of every time I see a k, I put in a k plus 1. And then so my last step's going to be just to clean it up. Maybe you don't like to do it this way. This is my favorite way of doing it. And so that's what I get. And I do start at 0 like my math lab wants me to. And yet I keep the integrity of the series. All right, so all done here. Take care. Have a great day.